Welcome to the Boolean Brain. In continuation to the LeetCode Daily Challenge series, we are working on to solve the daily challenge from the LeetCode. We are on the day 4th. Let us try to take a look at the today's problem statement. The title says 4 divisors. Given an integer array nums, return the sum of divisors of the integers in that array that have exactly 4 divisors. If there is no such integer in the array, return 0. So the inputs is given us as an integer array, and we have to find the sum of the divisors of integers which have exactly 4 divisors. So as you can see, we have 21, 4, 7. So 21 has 4 divisors, 1, 3, 7 and 21. Similarly 4 has 3, 1, 2, 4. 7 has 2, 1 and 7 only. So out of these 3 elements, only 21 is able to satisfy the condition of having exactly 4 divisors. So we simply add the sum of all these divisors, which is able to make to 32. We return the 32. Similarly for 21, again for 21 it has these 4 divisors and the sum is 32 plus 32. We return 64. Now in this case, the input is 1, 2, 3, 4, 5. So as you can clearly see, there is no such element in these 5 elements which has 4 divisors. So in that case, we simply return 0 as the default answer. Okay, now try to take a look on how we are able to calculate the divisors of a given integer. For example, let us take a look at 21. As you might be aware, in order to find the divisors of a given number, the brute force approach is simply having a loop starting from 1 to that particular number, and at each stage check if that particular number is able to divide 21 fully or not. If the modulo operation on 21 is 0, that means that number is successfully able to divide, and that is a divisor. So as you can see, 1 can be divided by 21 can be divided by 1, so 1 is one divisor. Similarly, next is 3. 3 into 7 is 21, that is one divisor. Next element which divides 21 is 7, but if you can see, 7 is already here. 7 into 3 is 21, so we don't need to include it. So if you ask me about the solution for this, so you might also be able to think of the brute force approach. For while iterating on each of the element from the integer array nums, what we can do is have a simply loop starting from 1 to this particular number and keep a track of count. If the count is exactly equals to 4, and then we should be we can have a running sum and that can be added. But for this brute force approach, the time complexity is big O of n, where n is the length of the nums, multiplied by, for each of the element we need an extra loop starting from 1 to that particular element, so n into m. So let us take a look at the constants. The constant says the total length is 10 to the power 4 and the maximum element at a given index is less than equals to 10 power 5. So you can see the total brute force complexity goes 10 into 4 into 10 into 9, 10 into 5, so which is equals to 10 power 9. So I think which is a pretty huge, and most likely the interviewer would ask you to optimize this further. So how do we optimize this? In order to optimize this problem statement further, if you notice carefully one thing, after a certain point, while iterating from 1 to the given number, after a certain point you will find all the other factors or the other divisors that you will find are duplicated. That is because, let us understand that with the help of example. If I want to solve 16, so let us try to find the divisors for 16. 1 into 16 is 16. Next is 2 into 8, which is also 16. Next is 3 cannot be divided. 4 into 4, it's 16. Now what is this next element that is a divisor? Next is 8. 8 into 2 is 16. but if you carefully observe, 2 into 8 is already repeated. So this after 4 all the elements that are the divisors are basically the repeated elements. The next is 16 into 1 is 16. So all these 4 elements are basically the duplicate itself. So we don't really need to go after a certain point. And what is that certain point? It is, if you carefully observe, 4 is the square root of 16. So in order to optimize, instead of simply having a loop running from 1 to that particular element, we can only run a loop from 1 to the square root of that number. This way, how we can be able to reduce the time complexity very significantly. Now let us try to code the approach, optimized approach. Now we are starting a loop right from the elements from the nums. I is initially assigned to 0, I is less than nums dot size I plus plus. Now I need a global sum to return, so I declare a global sum. Now I need to start a loop right from 1 to the square root of a given number, so I'll add another loop which would start from j equals to 1 and j square root of, so it's a square of j is less than equals to nums of I j plus plus. Okay, now here we want two variables. Sorry, in for each element we need to keep a count of divisors, and we also need a local sum. Okay, now we add a condition here. If nums of I modulo j exactly equals to 0, this means j is a factor, j is a divisor. Okay, so we simply increment the count by 1. Also we add the sum to this. Okay, what else? If j is a divisor, if in this case 1 is a divisor, I also need to add 21. So how will I get 21? 21 is basically the quotient, right? So I will add the quotient, nums of I divided by j. But there is a catch. In case of 4, if the quotient is same as the divisor, in that case we don't really need to add it twice. We can only get away with 1. So I can add a condition: if the quotient is not equals to j, then only I would add the count as well as total sum. In this case I will add the quotient. Okay, now since we are updating the count here, I can simply add a check. If count is greater than 4, I can simply break the condition here, because that is no longer a eligible number to consider, so we can simply break. Now once this internal for loop is finished, I can check if the count of the factors of the current number is exactly equals to 4. We can simply add the sum to the total sum. Okay, let us try to run this. Yeah, sample test cases are passing. Let us try to submit this. Yes, the problem statement is successfully accepted. So now for this optimized case, let us try to find the time complexity. Now you can carefully see the outer loop is running from for the entire length, and the inner loop is going till only the square root of the given number. So the time complexity would be big O of n for the outer loop into square root of the m. So this is the time complexity. Space complexity, we are not using any complexity in both the cases, so space complexity would be 1. I hope the approach, the code and the time complexity and space complexity is clear to you. If you are having any doubts, please do let me know in the comments. Thank you.